review of atoms. Your key concepts for this video are: describe the three main subatomic particles that make up an atom, explain how atoms of different elements differ, and know what are isotopes. So, let's review real quick. Atoms are the smallest particle that can still be considered an element. So, gold at one atom has the same properties as a huge chunk of pure gold. They're both still elements, but atoms are the smallest you can get. Now, when you bond multiple atoms together, you create a molecule. Different molecules bond together create cells. The same cells mix together to create tissues. Different tissues make up organs. Different organs make up organ systems. Different organ systems make up organisms. The same organism will make up a population. Different populations make up communities. Different communities, plus those abiotic factors, make up ecosystems. And all the ecosystems in the world together make up the biosphere. Let's talk a little bit more about atoms at a small level. There are three main particles. You probably already know them. We've got our protons, our electrons, and our neutrons. Now, our protons and our neutrons are both located in the nucleus, the center of our atom. Our protons, our happy positive protons, have a positive charge, whereas our neutral neutrons have no charge. Now, orbiting around the nucleus is our electrons. These are like enraged. They have a negative charge. So you can see this on a model. Here in our nucleus, we have our protons and our neutral neutrons, and around the nucleus, we have our electrons. So let's talk about atomic mass. Every atom has mass. I know it's small because it's hard to think of, but we do actually have it. That atomic mass is determined by the number of protons and neutrons in the atom. So the reason it doesn't include electrons is electrons are tiny. Look at this little bird on this elephant's back. I guarantee you this elephant barely notices that bird is there. And if we were to mass this elephant with the bird or without the bird, the measurement would be very, very similar. This is because it's tiny. Protons and neutrons are like this elephant. Electrons are like this little bird. So when we're talking about the mass of an atom, we're talking about the protons plus the neutrons together. Another number you need to know about is the atomic number. Now this is the number of protons in an atom. Each element has a different number of protons. That's what makes them different and unique. So hydrogen has 1 proton. Helium has 2 protons. Carbon has 6 protons. You can't change the number of protons without changing what element it is. And that's very hard to do. That's a whole nother discussion. But there is something we can change. We can change the number of neutrons. So if we have an element, say carbon here, there's 6 protons, so it's definitely carbon. But let's add an extra neutron. Now there's 7 neutrons. This would be called carbon-13, and it's an isotope. It's still carbon, but it's just got a slightly different number of neutrons. You can also add another one. Now we've got carbon-14. You might have heard of it from like carbon-14 dating. We use it for determining how old things are. You can think of isotopes kind of like flavored Oreos. You've got your basic Oreo, which is the one that we tend to talk about, but then you've got your other flavors like the peanut butter or the mint. They're all still technically Oreos, but they're a little bit different. That's it. Please make sure your notes hit all the key concepts and vocabulary, and for a challenge question, try this. Are the protons that are found in the nucleus of gold the same as the protons found in the nucleus of hydrogen? Why or why not?